Okay, so I'm going to go through each problem of the Chapter 5 review. I did mention in the comments where each problem starts, at what time it starts. All right, for number 1, a couple places to start here. D and 97 are a linear pair. So if I take 180, subtract 97, I'm changing my colors here. So, 180 minus 97 is going to give me 83. So D is 83. Now I also notice that I have some parallel lines here, right? These two lines are parallel. So D and C are same side interior angles. They are supplementary. Or you can think about it as 97 and C are alternate interior angles. So C has to be 97 as well. I'm going to write that over here. And D, we said, was 83. Over here on the left, we have an isosceles triangle. This is isosceles. Okay, so if the vertex angle is 26, I can take 180, subtract 26. What I have left over, I need to divide into these two angles, right? So 180 minus 26 gives me 154. Divided equally among the two angles, I get 77. So these two angles here are 77, those base angles. Now, A and B are going to be congruent because these two angles right here are a linear pair. So 180 minus 77 gives me 103. So both A and B are 103. Okay, now E, a couple ways you can look at this. E, you can use the pentagon, right? You can use that pentagon. We know there's 540 degrees. Subtract what you know. That'll work. Or, again, use those gray parallel lines that I made. This 26 and E are same side interiors or consecutive interiors. So I can do 180 minus 26 and I get 154. Okay, for problem number 2, a couple of things to do here. First of all, I got some linear pairs going on here. So this linear pair here, I'm going to get 140 degrees. On the right-hand side, use my linear pairs, I get 80 degrees. Now, if you look at where Y is, these two angles here are congruent, right? Because they both have one tick mark. The angle Y and its exterior angle makes a linear pair. And so does the other one. They both make linear pairs, which means these two angles here that are unnamed have to be congruent. Okay, so really what we've created is an isosceles triangle. Okay, so I need to find my base angles. So 180 minus 80 gives me 100. Split it equally among the two angles, I get 50 and 50. Now, using my linear pairs, I get that Y is 130. All right, so now I labeled both angles as 130. Now the big overall polygon, this is a heptagon, which means 7 sides. So I can use that formula of 180 times n minus 2. In our case here, it's 7 minus 2. And you should get 900 degrees. So that's the sum of all the interior angles. So if I were to take my 900 degrees, and subtract all the angles that I do know, the 130, the 130, the 140, and the 135. I'm going to subtract all of those. Let's see, 135 and 140. Okay, I am now left with 365 degrees. I have to split that 365 degrees equally among my 3 remaining angles. So divide that by 3, you get 121.6 repeating, 121 2/3 if you want to think about it that way, 121.7. I don't really care how you think about that. So this is 121.7. All right, and we already solved for Y. We know that Y is 130 degrees. Okay, number 3. Number 3 has been challenging, it seems like. So a couple things here. Let's find our vertical angles because those are always nice and easy. I know this has to be 85. I have a vertical angle here with my 44. Okay, I can also use my triangle, this little triangle on the left. Oops. This little triangle on the left here. Take 180 minus 85 minus 44. I'll get 51 for C. Okay, then I'm going to do my linear pairs up here at the 85, so I know that has to be 95. My linear pairs down here at the 44, that has to be 136. Down here at the bottom where A is, this is an isosceles triangle. So if this angle is 44, this angle has to be 44. Okay, so those are base angles, right? Now I can find my vertex angle. So 180 minus 88 gives me 92. All right, so now let's start using our parallel lines. And we actually have two sets of parallel lines in this one. We have this one right here, and this one are parallel. So let's start there. All right, so let me go back. All right, so angle C there, that 51 degrees, is an alternate interior angle to this angle right here, 51. All right, so look for the Z. Here's my Z, that's 51 degrees. I can do the same thing for B. My Z is just going in the opposite direction. Right, so if we have 44 degrees down here, B is also going to be 44 degrees. All right, I have some linear pairs, that's 51. Then if I find that missing angle, that linear pair with my 51, so 180 minus 51 gives me 129. All right, so now I could have also found that out if I looked at that 129 when I was solving for that is the same side interior or consecutive interior with angle C. So angle C and this 129 here, that 51 and 129 have to be supplementary. All right, so now let's go and look at the other set of parallel lines. So we have another set of parallel lines right here and right here. Okay, so I have more alternate interior angles. So if I look at, let's see, the green ones here. So if I do, here we go. This 44 right here is going to be an alternate interior angle with this one right here. So I know this one also has to be 44. I have vertical angles here I have not filled in. I also have linear pairs that I didn't fill in yet. Okay, so now I have a triangle on the right hand side here. I can find my missing angle is 92, which means this vertical angle is 92, and the linear pair here makes 88. I could have also, again, done the same side interior with this 88 and this 92 because they're the angles between the parallel lines here. All right, next, another thing I can do, this big triangle right here, I now have two of the three angles. So if I take 180, subtract 44, subtract 51, I'll have D. So that makes D 85. Okay, so now I can use that triangle on the top, right? I can solve and I can get 180 minus 85 minus 51 is 44. Vertical angles here, I have another 44, and this then becomes 136. I have that last little triangle up here. So 180 minus 92 minus 44 is going to give me another 44. All right, so we can fill in all of our answers here. A is 92, B is 44, C is 51, D is 85, E is 44, and F is 136. All right, for this next problem here, ABCD is a square. ABE, oh, I see my letters here got cut off. So this is a B, this is supposed to be a C, sorry about that. Okay, so ABE is an equilateral triangle, and we want to solve for X. So first of all, we know that if we have squares, we have 90-degree angles, right? All those angles are 90 degrees. Okay, if we have an equilateral triangle, that means all three angles have to be congruent. So 180 divided by 3 gives me 60 degrees. So this angle is 60, this angle is 60, and this angle is 60. Okay, so now down at angle B, if I know the whole big angle B is 90, part of it is 60, this has to be 30. The other thing I see is since we have a square, AC is a diagonal. So remember with squares and rhombi, the diagonals bisect the angles. That means that this has to be 45 and this has to be 45. Okay, now I can focus on just this triangle. And I can take 180 minus 45 minus 30, and I'm going to get 105. Okay, the next one, we have the ABCDEF is a regular hexagon. Okay, if that's the case, then that means that we have a bunch of congruent sides here, right? 1, 2, 3, 4, 5, 6 congruent sides. I can also solve for each individual angle. Right, so if I take 6 minus 2 times that times 180, I get 720. Divide that by 6, that means every single angle has to be 120 degrees. Okay, so every one of those angles is 120 degrees. Then it also says that ABGD is a square. Okay, so now here's what's so important that people miss. ABGH, sorry, I think I said the wrong letter, is a square. Right, so all 4 sides have to be congruent. Well, notice I already have 1 tick mark here, so I have to use that 1 tick mark again. So if it's 1 tick mark, 1 tick mark, 1 tick mark, 1 tick mark, this is huge for us because now we can look at this triangle, and this triangle now is isosceles. All right, so we know that the angles in our square are 90. I also know that the angle for my hexagon is 120, which really makes this angle then 30 degrees. All right, so now I can take 180, subtract 30, I get 150. Split it evenly among the 2 base angles, I get 75 and 75. Now the 75 degrees and the x make a linear pair, so that gives me 105. Number 6 says, how many sides does a regular polygon have if each exterior angle measures 30 degrees? So you have to remember the sum of the exteriors is always 360 degrees. Doesn't matter how many sides. So I want to know how many groups of 30 degrees are there in 60 degrees. So 360 degrees, I apologize. So 360 divided by 30 gives me 12 sides. Number 7 says the sum of the measures of the interior angles of a polygon equals the sum of the measures of the exterior angles. So how many sides does it have? All right, so the sum of the interiors is our 180 times n minus 2. The sum of the exterior is 360. It says that they're equal. So this is what I need to solve for. So I can divide both sides by 180. So I have n minus 2 equals 2. I would need to add 2 to both sides, so I get n equals 4. So if there are 4 sides or quadrilateral, then the sum of the interior is equal to the sum of the exterior. Number 8, if the sum of the measures of the interior angle of a polygon is twice the sum of its exterior angles, how many sides does it have? All right, so we know, again, the sum of the interior is 180 times n minus 2. We know the sum of the exterior is 360. But it's saying we have more of the interior, right? So what I really need to do is I want to double the exterior to match the fact that the interior is doubled. All right, so I have 180 times n minus 2 equals 360 times 2 is 720. If I divide by 180, I get 4. Oops, sorry, I scooped up there. If I take 720 divided by 180, I'm going to have n minus 2 equals 4. Add 2 to both sides, I get n equals 6. All right, for the next one here, the top figure is a kite, the bottom figure is an isosceles trapezoid. So with kites, you have to remember that the non-vertex angles here are congruent. So if that is 137, then this angle has to be 137. Then this base angle is marked as being congruent to the angle in the kite, so that has to be 137. Let's go back to our kite and finish that. We know every kite, since it is a quadrilateral, has 360 degrees. So take away the three angles that I know, and I can get that x is 64 degrees. Okay, now with my parallel, or my trapezoid, we have parallel lines here, right? So these two angles have to be supplementary because they're the angles between the parallel lines. There's the consecutive interior. So 180 minus 37 gives me 43. So x was 64 and y was 43. Okay, we have a kite again here. So first of all, you need to remember that the diagonals are perpendicular. Okay, so we have right angles there. So if we know all of those are right angles, we can solve for this angle right here. So 180 minus 90 minus 41 is going to give me 49. Okay, the other thing I want you to remember is that the diagonal actually bisects, oops, sorry, wrong pen. The diagonal bisects these vertex angles, right? So if this top angle here is 41, this has to be 41. Which means then since we have 41, 90, this has to be 49. And again, because my non-vertex angles are congruent, right? If that part's 49, this has to be 78. Okay, now I can solve for x because I have two triangles there. I have two triangles that are exactly the same. They are congruent. So 180 minus 78 minus 90 is going to give me 12. This has to be 12 and this has to be 12. So x here is 12, y is 49, and z is 90. All right, so number 11, there's a lot going on in here, but it's not too bad once we start breaking it down just a little bit at a time. So I always try to find vertical angles and that sort of thing, but we don't really have a whole lot of those here. So I'm going to start up here, I think. I see I have a 40-degree angle and a right angle at this little triangle right here, which means if this is 40, 90, this one here has to be 50, a little tiny one. This has to be 50, which makes this 50. And notice that has one tick mark, so I'm going to find my other angle that has one tick mark, so that's 50. All right, B then, and its vertical angle are both going to be 130 because they're a linear pair. Okay, next, I see this big triangle right here. Okay, it has two angles that are congruent, and I have the third angle. So 180 minus 58, split it equally among the two angles, and we get A is 61, which makes this angle here 61. Okay, so now I can find my missing angle in that little teeny tiny triangle there. So 180 minus 61 minus 50 gives me 69. So this little tiny angle here is 69, which makes E then 111. All right, so now let's fill in what we know so far. So E we know is 111. We know A is 61. B we know is 130. All right, so the next thing I see here, I see we have a quadrilateral right here. All right, we know every quadrilateral has 360 degrees. So let's take away what we know. We can take 360 minus 50 minus 90 minus 76. I'm left with this angle. So this is 144. So that makes this angle 144. I can use my linear pairs. So 180 minus 144 gives me 36. And this is 36 out there, and I don't think we're going to need that one, but that's okay. Now we can look at this triangle. We're missing just one angle, so 180 minus 50 minus 36 gives me 94. So this angle here is 94. The vertical angle there is 94. Now I can use my linear pairs. So 94 minus 180 is 86. Back down here to that 50 degrees, I can use my linear pair. I didn't do that yet. So that should be 130 and 130. My vertical angle is 50. Now I can use this big triangle. Right, I have this big triangle here. I know 2 of the 3 angles. So 180 minus 70 minus 50 gives me 60. Let's see what else we need to know still. Let's see, we haven't found C yet. Where's C? Oh yeah, we did. C was 130. We haven't found D, found E, F. There's F is 86. G we have not found yet, and H is 144. All right, so the next thing I see, I have 1, 2, 3, 4, 5 sides. So we have a pentagon right here. So a pentagon has 540 degrees. So if I take away what I know, so take away those 4, I get 147. So this angle is 147. So I do my linear pairs again. So I have 180 minus 147 gives me 33. So this little angle here is 33. I can do my little triangle, or I could do that quadrilateral on the left to get G. So I'm just going to do my triangle. 180 minus 50 minus 33 gives me 97. And then 180 minus 97 for that linear pair gives me 83. Do my vertical angles there. So G is 83. We still need D. Where is it? Okay, there it is. So we have this big triangle right here. So if I take 180 minus 88 minus 33, we're going to get that D is 59. Okay, again, we have a kite. This time we're looking at some legs as well, or sides as well as the angles. So congruent parts here, we have 10 and 10. It does tell us that the perimeter is 64. Okay, so if I take 64, subtract 2 legs, I do know, that's a total of 20. That leaves me with 44. Now I have to divide by 2. I'm going to divide by 2 here because we have to split it equally among the 2 remaining legs. So this is going to be 11 and 11. Now again, remember that my non-vertex angles are congruent. So if this is 96, this has to be 96. Then I can take 360, subtract 96, 96 and 24, and I get that Y is 144 degrees. All right, so we figured out A was 11, X is 96, and then Y is 144. Okay, on this next figure here, you have to recognize you have a parallelogram because opposite sides are parallel. So we also know opposite sides have to be congruent. So A and 31 have to be congruent, and then B and 38 have to be congruent. 1 and 38 because opposite sides are congruent. We also know opposite angles have to be congruent, which makes X 47. And then either X and Y, or 47 and Y, depending on how you want to look at it. These are 2 angles between parallel lines, so we know they are supplementary. So if I take 180, subtract 47, I'm left with 133. Not that they asked, but this angle would also be 133. Okay, number 14, PQRS is a rectangle, so I need to know opposite sides are congruent, all angles are 90 degrees. We also know the diagonals are congruent and the diagonals bisect each other. All right, so we know that OS is 16 and SRP is 20 degrees. Okay, again, don't forget we have all these parallel lines and everything, right? Okay, so OQ. Well, first of all, let's just label everything. It might be easier. So I'm going to change all my side lengths here to 16, to blue. So if that's 16, this has to be 16. Remember, diagonals are always bisected in a parallelogram. But in a rectangle, the diagonals are also congruent. So actually, all of these parts here are 16. So OQ has to OQ has to be 16. SQ is going to be that whole diagonal, so that's 32. So now let's talk angles. So when you have your rectangle, remember all angles are 90 degrees. So that little angle that I gave you is 20. This one has to be 70. All right, then we have alternate interior angles. So that 20-degree angle is also going to be down here, which means this has to be 70 as well. And then keep in mind, because these are all congruent, we actually end up with those isosceles triangles. So these base angles are going to be congruent. Then same thing with 70 for these base angles here. Then I can use my triangle, and then 180 minus 70 gives me 140, so that gives me 40 left over. Okay, this has to be 40, and then use my linear pair. I have 140 and 140. So angle QRS, that whole angle there is 90. Angle RQO here has to be 70. And then angle SOR has to be 140. 16. OQ has to be 16. Oh, sorry. Okay, number 15. KLMN is a square, and we know that NM equals 8. All right, so with the square, remember we have all those right angles. We know diagonals are perpendicular. And we just talked about in another problem how the diagonals bisect the angles. So all of these angles end up being 45 degrees. So let's say angle OKL. OKL here has to be 45 degrees. MOL is 90. Then the perimeter of KLMN, keep in mind if each side is 8, 8 times 4 is 32. Oops. ABCD is a rhombus. AD equals 11. DO is 6. And the measure of angle DCO is 25. Okay, so we just talked about how the diagonals are bisecting the opposite angles. Oops, that's 25. So all 4 of those angles there have to be 25. We also know that the diagonals are perpendicular. Okay, so now I can find all the other angles there at D and at B. So 180 minus 90 minus 25 gives me 65. So all of these angles here are 65. We also know the diagonals bisect each other, right? So maybe I should have written that in blue. This is 6, this is 6. All right, so let's see what all we need to know. OB we have labeled as 6. BC, we know all side lengths here have to be 11 because it is a rhombus. All right, so BC is 11. The rest are angles. So measure of angle AOD. AOD, that's got to be 90. The measure of angle DAB. DAB, that's the whole big angle, so 25 plus 25 is 50. The measure of angle ABC. So we have ABC, so this big angle here has got to be 130. And then OBA. OBA here is 65. Okay, for number 17, it's one of those big angle puzzles. What's kind of different about this one is that you really don't have any angles to start with in terms of them just giving you flat out numbers, with the exception of, we know this has to be 90 degrees right here. Okay, so I'm going to start over here on the left. We have a hexagon. So I know there's 720 degrees in every hexagon. Divided by 6, we get, or 720 degrees. Divided by 6 is 120. So all of these are 120. And just like with problem number, I believe it was 1. No, I'm sorry, it was problem number 2. We have where that 120 is a linear pair with B there. So that has to be 60 degrees, and this has to be 60 degrees. If I look at that triangle I'm working on, angle C then has to be 60 degrees, which makes this 60 degrees. We know that L and K here are parallel. Those two lines are parallel. So that 60 degrees I just filled in angle D are same side interior, so that has to be 120. Now, here at E, these two together are a vertical angle to this angle here at D. So that means this whole thing has to be 120, so it's got to be broken evenly into 60 and 60. So this is 60 and 60. That leaves me 60 here and 60 here. It's a lot of 60s. All right, so now let's go over to my pentagon. Let's go over to the pentagon here on the right. So a pentagon we know is 540 degrees. If I have to divide that by 5, that's 108 degrees for each one of these angles. All right, so I know then that G has to be 108. I'm going to use my linear pair here to get 72. Okay, then let me back up over here. This is 108, which means this linear pair here makes 72. I can focus on this little triangle there. So 180 minus 60 minus 72 gives me 48. So I know this is 48. Again, I know this angle is 108. So now I can use the fact that the three angles right here equal 180 degrees. So if I take 180 minus 48 minus 108, we get 24. So this little angle right here is 24, which is M. Okay, now let's look at that little triangle where M is. So if I take 180, subtract 24, subtract 72, we get 84 degrees. So this angle right here is 84, which then P is a vertical angle, so that has to be 84. So I have A is 120. We have, let's see, angle B is 60. Angle C is 60. Angle D we know is 120. Angle E is 60. F, oh, we didn't get F yet. So we have the triangle that F is in right here. So that means 180 minus 90 minus 60 gives me 30. So that's 30 degrees. G we found is 108. M is 24. And then finally P is 84. All right, the next one is a proof. Okay, so we're going to write out our proof here. So it's given parallelogram GOAT. We want to prove that O is congruent to T. I'm trying to prove that opposite angles are congruent. Okay, now in this one, they gave us the fact that we have a parallelogram. So let's start there. We have parallelogram GOAT. That's given. Now, we need to actually make a statement here that we have parallel lines. Sorry, I think I muted myself. We know that OG is congruent to TA. I'm sorry, not congruent. We know they're parallel. Let me erase that. We know OG is parallel to AT. And we know that the other direction, GT, is parallel to OA. This is by definition of a parallelogram. Okay, so now that we have parallel lines, now we can use our alternate interior angles. So we know that 1 and 4 have to be congruent. So angle 1 is congruent to angle 4 because of alternate interior angles. We also know the same thing about 2 and 3. So angle 2 is congruent to angle 3 by alternate interior angles. Then they share GA. So we know that GA has to be congruent to GA because of same segment. So now I have two congruent triangles, right? I have three congruency statements. They're a good combination. So we have triangle GAT is congruent to triangle AGO by angle side angle. Therefore, angle O is congruent to angle T by CPCTC. All right, the other thing we could have done on this one, and I didn't put this on the review answer key, but the other thing you could have done is after you make these statements that these two angles are congruent, We could have actually said angle O is congruent to angle T because of the third angle conjecture. Because once you have two sets of congruent angles, the third angles must also be congruent. So that's an option. But this proof would really be the same if I were going to do like opposite sides congruent, right? The whole thing would be the same with the exception of this last step. Okay, last proof. We have given kite SNOW with SN congruent to SW and NO congruent to OW. All right, so we'll start with my given. We have kite SNOW. We know that SN is congruent to SW. SN and SW, that's given. We also know that NO is congruent to WO. That's also given. Okay, so now I'm trying to create those congruent triangles because I want to show that angle 1 and 2 are congruent. So I can say that SO is congruent to SO because of the same segment or reflexive. Oops. Okay, then I have three congruency statements. It's a good combination. So I know that triangle SNO is congruent to triangle SWO by side, side, side. Therefore, angle 1 has to be congruent to angle 2 because of CPCTC.